All right, in this lesson, we are going to talk about scatter plots and linear regression. And so a scatter plot is a statistical tool used to analyze data and determine if two variables are related. Okay, and so when we want to write an equation to fit this data, we call it the line of best fit. And we use this line to make predictions. So if we're given an input value, we want to find the output using that equation. If we're given an output value, a y value, we want to solve it to find the input x. So it could go either way. So you have to pay attention to whether you're given an input or an output. And we'll do that towards the end. Okay, and so there's two types of statistical relationships that you will be asked to determine. It's whether something is causation or association. And so causation is kind of what it sounds like. One variable causes a change in the other. And so that means the two variables are related and that changing one variable will change the other. An association is where they are unrelated. Okay, meaning if you change one variable, it will not change the other. Okay, and so usually some of these you could argue either way, so try not to be too creative when you are trying to come up with a justification. So looking at some examples, we're comparing the amount of flour to the amount of bread baked. Well, since you need flour to bake bread, decreasing your flour would decrease how much bread. So they do cause changes in the other. So this would be causation. Okay, the number of mailboxes and the number of firemen. Those are completely unrelated. So this would be association. The number of students and the number of student desks. If I have more students, I'm going to need more desks. So this would be considered causation. The number of students and the size of our school. More students, we have a larger school. So once again, causation. A change in one would cause a change in the other. The number of cats and number of dogs. These are unrelated. Technically, you could argue saying if you had too many cats, you can't get dogs. And so don't get too creative. Just know that if you change the number of cats, it's not going to change the number of dogs. Those are unrelated variables. Okay, so when we do have causation or a correlation, we can have a positive correlation, meaning our scatter plot kind of forms a line with a positive slope. We could have a negative correlation where our points are falling towards a line with a negative slope, or no correlation at all. They're just all over the place. You can't even make a line out of them. Okay, and so our calculators can actually tell us how correlated or how linear the relationship is. Okay, and so you're going to do this using what is called the correlation coefficient, and it's denoted by the letter R. R is your correlation coefficient. And the closer you are to -1 and +1, that's perfect. Okay, so if you have R equaling positive or -1, that's perfect. Okay, and so the closer to 1, the stronger the relationship. Okay, and so if you are really close to -1, that's strong negative. If you are really close to +1, that's strong positive. Okay, strong. And so I treat the value of R kind of like a test score. If you have a 0.7, whether positive or negative, if you are bigger than 0.7, that's like a test score of 70. That's a strong performance. You passed the test. Whereas if you start scoring below a 70, that's when you have a weaker correlation. So the closer you are to 0, the weaker the performance, the weaker. And so we're close to 0 from the negative. Here we're close to 0 from the positive. Those are weak. And then if you have an R equals 0, there's absolutely no correlation whatsoever. Okay, and then of course we have the moderates that are in between. And so a good rule of thumb is just ignore the negatives and treat it like a test score. And so we'll practice with that. Okay, and so here we're given some data, and we are going to practice getting the line of best fit. These are the directions for a TI-84 calculator, but you will have Desmos embedded into your test. And so I want to show you how to use Desmos because it's a lot more user-friendly and there's less steps. And so I'm going to open a Desmos testing browser. This will be the version you have embedded in your test, and you can access this through any web browser. And so everybody has access to this. Okay, and so your first step when you are given a table, I've already filled in the answers here, but when you are given a table, you are going to click the plus sign and choose table. This is how you're going to input your table into Desmos. And so you type all your X's. And you just hit this blue button to move to the next row. And then type all your Y's in the Y1 column. Okay, and so once you have your table, go to a new line and you're going to type, and I'll write this on your notes, Desmos. You are going to type Y1 and it'll automatically put it in the subscript. So you just type Y1 tilde, and I'll show you how to get to that symbol. And then since we want mx plus b, you're going to do mx1 plus b. It's important, you're just typing in y equals mx plus b. The only difference is you're putting these ones next to the variable and you're using a tilde. Okay, so all this is going to give you is y equals mx plus b for this specific table. Notice there's ones, okay? And so you can go to y1, and to get to tilde, you're going to click the ABC, and the tilde is right under B. Y1 tilde, and while you're here, do M, X, and then go back to the numbers 1 plus back to the letters B. Okay, and so here it's giving you everything you need. And so we can see that M is 1, that's our slope. We can see that B is 2. And then the R value, since we're treating it as a test score, just keep 2 decimal places. So ignore the R squared. R equals 0.95. And so that means our y equals mx plus b equation is y equals 1x plus 2. Okay? And so if you want, you can type that in, but it also graphs it for you. That's what's so great about Desmos. This red line that it graphed through my table of points is the line of best fit. And so now we can use this line to make predictions. Okay, so the first question asks us, what is the strength of the equation? And so strength comes from R value. Okay, treat that 95 like a test score. That is strong and it's positive. It's a strong performance and it's positive. If there was a negative in front of it, that's how you would know it was strong negative. This is strong positive. Okay, and so now we are going to use our equation. And so if you don't want to use the calculator, we can just plug the values in. Okay, and so I'm going to get rid of the answers here for a second so you're not distracted. Okay, and so here it says f of 5. Okay, that means x equals 5. Okay, and so you can use your equation up here and plug in 5 for x. And so that would give me y equals 1x plus 2. And you don't even have to write the 1. 1 times 5 is 5, plus 2 is 7. Okay, and so we would answer 7 for this. Okay, you could also, once you realize it's x equals 5, you can type in x equals 5 and click on the point of intersection, and you know that the y is 7. Okay, here they're telling me y equals 3. Notice that 3 is not inside the parentheses. So I am given y equals 3. So that means I take my equation and I plug in 3 for the y. So that would give me 3 equals x plus 2. And we need to solve it for x. So we would first subtract 2. And that would give us x equals 1 as our answer. So we would tell them x equals 1. For this example, we needed to give them the x and not the y. Okay, if instead you wanted to use this Desmos, you would type in the given information. The given was y equals 3 because 3 is out here. And so if you type in y equals 3, click on the intersection, you see that the x is 1. Okay, here, once again, we're given x, and so x equals 3 is what's given. And so we take our rule, which is x plus 2, and we plug in the 3. That would, oh, not 3, 15. I don't know what I'm saying. 15. X is 15. 15. And so we end up getting 17 for our y value. So we would report back that 17 was our answer. In the first example, when we plugged in 5, we got 7. In the second example, we plugged in 15 and got 17. Okay, once again, if you want to type it in, it's x equals 15. You would go to where the x equals 15 line is, and it tells you the y is 17. Okay, here we're given y equals 8. So using the calculator, y equals 8 tells me the x is 6. If you want to do it by hand, we plug in 8 for the output and solve. So subtract 2 from both sides, and we would get x equals 6. Okay, and so when the numbers are nice, I just do it by hand. I don't really use the calculator unless the numbers are ugly. On this second example, the numbers get kind of ugly. And so we have the same x values, we just have different y values. So I'm going to just change my table. And you can kind of see that the y's are decreasing. This is going to be a negative slope. Okay, so when I type y1, I'm going to write that again for you. We're doing y1 tilde m x1 plus b. The ones only go with the y and the x because it's referring to the table where it says x1, y1. Okay, so y1, go to ABC, tilde m x1 plus b. Okay, and so here we don't have as pretty of numbers. Our slope was negative 1.6, and I just keep 3 decimal places, and then 15.366 would be the b value. The r value, notice this time, is negative, so negative 0.98 if we round to 2 decimals. And so my equation, the m goes with x, the b goes outside. Okay, and so to determine the strength, this 98, that's strong. This negative means it's negative. Strong negative. Whenever you have a negative slope, you'll have a negative r value. These signs will always match. And so just be careful, they should match. All right, and so now to use our equation, I'm gonna get rid of the answers. That's how I did it in the calculator. Here I'm using Desmos, which is way easier. Okay, so here, all you have to identify is that your x value is 8. Here, our y value is 12. Here we're given x equals 2. Here we're given y. Okay, so if it's inside the parentheses, it's your x. Inside, so it's x. Outside, it's y. Inside, x. Outside, y. Okay, and so to use our Desmos equation, they graphed it. This purple line is our graph. And so we just need to type in for the first one, x equals 8. And so when x is 8, y is about 1.86. That's your answer. Okay, here we need to change it to y equals 12, which will be a horizontal line. And we get x is about 1.99. And then I'm going to go ahead and do the y equals 6 since I have the y. X is about 5.55. And then here, I need to type x equals 2. Should be a vertical line. So when x is 2, y is about 11.99.